Hi again, this is Mrs. Ricard, and today we're going to talk about right triangle trigonometry. Back in geometry, you probably talked about the fact that when you have a right triangle, that's a triangle with one right angle, that all similar right triangles have ratios of their sides that are always the same. If they have the same angles, then the ratio of their sides are the same. So when we're looking at a right triangle, the side across from the right angle is called the hypotenuse. And when we look at one of the two acute angles, I'm going to look at angle A, the side that is not the hypotenuse that helps form that angle is called the adjacent leg. And the side that does not help form the angle at all, the one opposite, is called the opposite leg. So when you're looking at one of the two acute angles in a right triangle, the sine, which is spelled S-I-N-E, but they abbreviate it sine, is the opposite leg over the hypotenuse, the length of the opposite leg over the hypotenuse. The cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent, as you can see here. We use the acronym SOHCAHTOA to help us remember that. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. What you probably didn't talk about in geometry were the reciprocal trig functions. Cosecant is the reciprocal of sine. So since sine is opposite over hypotenuse, cosecant is the hypotenuse over the opposite leg. Secant is the reciprocal of cosine. So since cosine is adjacent over hypotenuse, secant is the hypotenuse over the adjacent. And cotangent is the reciprocal of tangent. So since tangent is opposite over adjacent, cotangent is adjacent over opposite. Excuse my dog. So when you know the lengths of two of the three sides of a right triangle, one of the things you learned in geometry was the Pythagorean theorem. The Pythagorean theorem says leg squared, well, I'll call it leg 1, plus leg 2 squared equals the hypotenuse squared. So if you know two of the three sides, you can always find the missing one. So here, one of my legs is 3, and my other leg is 5, and I don't know the hypotenuse. You may recognize this as a squared plus b squared equals c squared. 3 squared is 9, 5 squared is 25, 9 plus 25 is 34. So I take the square root of both sides, and the square root of 34 would be the C side, which in this case is segment SQ. So for this triangle, it depends which angle you're looking at, what you're going to call the opposite or the adjacent. I'm going to start by looking at angle Q. So I'm going to find all 6 trig functions of angle Q. A trig function always needs an object to act upon, so you always need to know what angle it's taking the sine, the cosine, the tangent of, and so on. So usually when I'm asked to find the trig functions of an angle, I start by writing out all 6 trig functions with the angle equal sign. You don't have to write the angle name, you can just write the letter of the angle. So in this case, if I'm looking at Q, then the opposite is 5. The adjacent is 3, and the hypotenuse is, as we found over here, the square root of 34. So the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. The cosecant is the reciprocal of sine, so that's going to be the square root of 34 over 5. The secant is the square root of, the reciprocal of cosine, so that's going to be square root of 34 over 3. And the cotangent is going to be the reciprocal of the tangent, so that's 3/5. However, Q is not the only acute angle in that right triangle. S is also an acute angle in that right triangle. So if I want to try to find the sine, cosine, and tangent and all the other trig functions of S, then I have to look at the triangle a little differently. Because if you look at angle S, the hypotenuse doesn't change because it's always across from the right angle. But the opposite side from S is 3, and the adjacent side is 5. So it still has the same hypotenuse, square root of 34, but the opposite and the adjacent have switched. So the sine is going to be 3 over the square root of 34, opposite over hypotenuse. Cosine is adjacent, 5 over hypotenuse, square root of 34. Tangent is the opposite, 3 over the adjacent, 5. Cosecant is the reciprocal of sine, excuse my dog, is the square root of 34 over 3. Secant is the reciprocal of cosine, which is the square root of 34 over 5. And cotangent is the reciprocal of tangent, which is 5/3. So now let's look at some actual angle measures. Notice I'm talking about 30, 60, and 45 degree angles here. Now again, thinking back to geometry, you learned that these were called special angles because they had certain properties, and then we had special triangles that had these properties. You learned that the sides of a 30, 60, 90 were in a ratio so that the length of the shortest side was half the length of the hypotenuse. So if you knew the short side, you'd double it to find the hypotenuse. And the length of the longer leg was the square root of 3 times the shorter leg. So we had these ratios, these numbers, we could call it x for the short side, then the hypotenuse would be 2x, and the long side would be x times the square root of 3. So we're going to use those labels. So if I'm looking at the sine of 30 degrees, here's the 30 degrees, the opposite is x, and the hypotenuse is 2x, and that would reduce to 1/2. For the cosine of 30 degrees, the adjacent leg is x times the square root of 3, and the hypotenuse is 2x. So again, the x's would cancel and you would get the square root of 3 over 2. And for the tangent, we'd have the opposite for 30 degrees would be x, and the adjacent would be x times the square root of 3, so that would reduce to 1 over the square root of 3. But remember, in a right triangle, the two angles, the two acute angles, are always complements of each other. They add up to 90, and then if you add the right angle, that makes the 180 degrees in the whole triangle. So the 60 degree angle is the complement of the 30 degree angle. And when we look at the 60 degree angle, the opposite is the x times the square root of 3, and the adjacent is the x, but the 2x remains the hypotenuse. For the sine of 60 degrees, we get the opposite, x times the square root of 3, over the hypotenuse, 2x, and that reduces to the square root of 3 over 2. For the cosine of 60, the adjacent is x, and the hypotenuse is 2x, so x over 2x reduces to 1/2. And for the tangent of 60, we take the opposite over the adjacent, so that's x square root of 3 over x, and that's just the square root of 3. In our 45, 45, 90 triangle, the two legs are the same length because it's an isosceles triangle. The two base angles are equal, so the two sides opposite them are equal. And using the Pythagorean theorem, you would find that the hypotenuse is x times the square root of 2. So the sine of 45 degrees would be opposite x over hypotenuse x square root of 2, and that reduces to 1 over the square root of 2. The cosine would be the adjacent, which is still x, over x square root of 2, which is still 1 over the square root of 2. And the tangent would be the opposite over the adjacent, x over x, which reduces to 1. Now I want you to notice that the sine of 30 degrees was equal to the cosine of 60 degrees. And the cosine of 30 degrees was equal to the sine of 60 degrees. The tangent of 30 degrees is not the same as the tangent of 60 degrees. But remember that we had our cosecant, secant, and cotangent? The cosecant of 30 degrees would be 2. The cotangent of 30 degrees would be the reciprocal of 1 over square root of 3, which is the square root of 3. So the tangent of 30 would be the same as the cotangent of 60. The sine of 30 is equal to the cosine of 60. The cosine of 30 is equal to the sine of 60. They're called co-functions because their angles are complements, which starts with CO. So the co-functions of complementary angles are equal to each other. And that's what it's saying down here. The sine of x is the cosine of the complement of x. Cosine is the sine of the complement of x. Secant is the cosecant of the complement of x. One of these should have been tangent and cotangent. I'll just add those on. So the tangent of x equals the cotangent of 90 degrees minus x, and the cotangent of x equals the tangent of 90 degrees minus x. So we have some identities, which are equations that are always true. The reciprocal identities basically just define secant, cosecant, and cotangent. We started with sine, cosine, and tangent. Sine is the reciprocal of secant. Reciprocal is just 1 over it. Sine is the reciprocal of cosecant. Cosine is the reciprocal of secant. Tangent's the reciprocal cotangent, and then the same thing's just represented the other way. Cosecant is the reciprocal of sine, secant's the reciprocal of cosine, cotangent's the reciprocal of tangent. Now, one thing that you may not have thought of, if we have opposite over hypotenuse, that's our sine, and then we have adjacent over the hypotenuse as our cosine. Remember, when we have division with fractions, we can rewrite it as multiplying by the reciprocal, and the hypotenuses cancel, and we get the opposite over the adjacent. This was sine, this was cosine. Sine divided by cosine is equal to tangent. So that's a quotient identity. Cotangent is just the reciprocal of tangent, so if tangent is sine over cosine, then cotangent is just the reciprocal. You just flip it over. And there's 3 identities that come straight from this being a right triangle. This one's the most obvious. If sine is opposite over hypotenuse, and we are squaring it, and cosine is adjacent over hypotenuse, and we're squaring it, then when I square these, I get opposite squared plus adjacent squared in the numerator, and hypotenuse squared in the denominator. The opposite and the adjacent are the legs of the right triangle, and the hypotenuse is clearly the hypotenuse. And remember, the relationship between those is the Pythagorean theorem. The sum of the squares of the 2 legs is equal to the hypotenuse. So if you square the sine of an angle and you square the cosine of the same angle, you get 1. Again, please excuse my dog. Same thing here. You can do it with the sines and cosines, opposite and adjacent, and you'll see it works out the same way. 1 plus tangent squared is equal to secant squared, and 1 plus cotangent squared is equal to cosecant squared. We're going to talk about those more in the future. But for right now, we're just going to use these identities to try to solve some problems. So, if the sine of x is 0.3, well, the first thing I like to do is I like to think of the trig function as a fraction myself. 0.3 is 3/10. Whoops, sorry about that. I want to find the other trig functions. Well, the easiest one to find would be the reciprocal. Sine's reciprocal is cosecant. So I just flip this over and I get 10/3. Now, I don't know the hypotenuse. Well, I can think of this as the opposite over the hypotenuse. I don't know that my opposite was exactly 3 and my hypotenuse was exactly 10, but I can think of that as a similar triangle that has the same ratio. So that means I can say, well, 3 was one of my legs, and I don't know the other leg, but when I square those and add them together, I should get the square of the hypotenuse. So that means 9 plus whatever the adjacent is squared equals 100. So if I subtract the 9, I get that adjacent squared equals 91. So the adjacent would be the square root of 91 if I'm using 3 for the opposite and 10 for the hypotenuse. Well, that means the cosine of x would be the adjacent square root of 91 over the hypotenuse 10. And the tangent of x would be the opposite 3 over the adjacent, the square root of 91. So the reciprocal of cosine would be the secant. So that would be 10 over the square root of 91. And the reciprocal of tangent would be the cotangent, which would be the square root of 91 over 3. Another way to think about this is to use our Pythagorean identity. Sine squared of x plus cosine squared of x equals 1. They gave us the sine as 0.3 squared, and we didn't know the cosine. But if we square 0.3, we get 0.09 plus cosine squared of x equals 1. If we subtract, we get cosine squared of x equals 0.91, and so cosine of x would be the square root of 0.91, which is the square root of 91/100ths, which is the square root of 91 over 10. Okay, the final thing I'm going to do is called solving the triangle. To solve the triangle means to find the length of all of its missing parts. Now in this case, I know that this is a right angle, so it's 90 degrees. And I'm told that this angle is 70 degrees. Since it's a right angle, that means the 70 degrees plus, I'll call that x, has to add up to 90 degrees. So if I subtract the 70, I get x equals 20 degrees. So now I know all 3 angles. Now I need to find the missing sides. Well, if I knew 2 of the 3 sides, I could use the Pythagorean theorem to find the missing side. But since I don't, I'm going to use trigonometry. You can choose to use either the 20-degree angle or the 70-degree angle. I have 2 sides that I have left to find. I'm going to label them A and B. And I'm going to use the 20-degree angle. I want to find A first. I just decided that. I could have found B first. So I need to use the pieces that I know. I'm using the 20-degree angle and A. For the 20-degree angle, A is the adjacent. The other side that I know for this 20-degree angle would be the opposite. So I don't know the hypotenuse, so I can't use sine or cosine because they both have a hypotenuse in them. So I'm going to have to use the tangent. The tangent of that 20-degree angle is the opposite 8 over the adjacent A. Now, tangent of 20 is a number that doesn't change. I'm not going to play with the calculator, though, until I get A by itself. So the first thing I would have to do is multiply both sides by A to get the A out of the denominator. So now I have A times the tangent of 20 degrees equals 8. And then I would divide by the tangent of 20 degrees to get A by itself. Now, I would use a calculator to find this value. 8 divided by the tangent of 20 degrees. You remember, when you put it into a calculator, either you need to make sure you put parentheses around this, or use the fraction template so that it knows 8 is the numerator and tangent of 20 is the denominator. And you also need to make sure your calculator's mode is set in degrees. We haven't learned about other angle measures yet, but we are going to very soon, and it's always important to check your calculator to make sure it's in the right mode. To find side B, which is our last missing part, B is the hypotenuse. So I avoid using something that I wasn't given when I'm solving a triangle, even if I already found it using something else. I prefer to use the things that were given to me. So I was given this side. I could use the 70. I used the 20 even though it wasn't given to me because I know that's the exact value. Where this one, you'd round off and it would be a mess. But I'm going to use the 70 this time, okay? So with the 70-degree angle, this side is the adjacent side. And I'm trying to find the hypotenuse. So the trig ratio that has adjacent and hypotenuse in it is the cosine. So I'm going to write cosine of 70 degrees equals the adjacent is 8 over the hypotenuse, which is B. Now I'm going to multiply by B on both sides to get the B out of the denominator. And that gives me B times the cosine of 70 degrees equals 8. And then I'm going to divide both sides by the cosine of 70 degrees. So that gives me B is 8 divided by the cosine of 70 degrees. And again, you could put that into your calculator to get a decimal answer.